हरिः कन्ना।
Now let's look into some of the important attributes of ND array or multi-dimensional array. So out of them, the first one is ND array.ndim. So the attribute is ndim. So what will it do? So it gives the number of axes of the array. And the second one we have is ND array.shape, that is shape. So the dimensions of the array. So this is a tuple of integers indicating the size of the array in each dimension. For a matrix with n rows and m columns, so the shape will be n comma m, a tuple of n comma m. That's what a shape gives. So the length of the shape tuple is therefore the number of axes. That's what the endim. The length of the shape is nothing but the endim that we are going to see. So let's and then after that we have nd array dot d type, sorry, nd array dot size. In size, the total number of elements of the array, that's what the size gives. When size, this is equal to the product of elements of the shape. For example, if our shape is 3 by 2, then the size of that nd array is 3 times 5, 3 times 2, it is 6 elements. If it is 3 by 5, it is 3 times 5, it's a 15 elements. That's what the size gives. And then we have d type. D type. So D type, an object describing the type of the elements in the array. So one can create a specific or specify D types using standard Python types. So additionally, NumPy provides types of its own, such as numpy.int 32, numpy.int 16, and numpy.float 64 are some of the examples. So then we have item size. Item size attribute gives the size in bytes of it will give you the size in bytes, basically in bytes of each element of the array. We will see each element of the array. It will give you the each element size in bytes. For example, an array of elements of type float 64 as item size 8, whereas and which while one of type complex 32 has item size 4, and it's equivalent to nd array dot d type dot item size. Then the last but not least, data. So data attribute, this the buffer containing the actual elements of the array. So normally we won't need to use this attribute because we will access the elements in an array using indexing facilities. So what we will do is, let's take one example and let's explore all these attributes one by one. That's what we are going to do. Okay, so let's begin with shape, and then we'll take to the n dimension. Clear? Yeah. Let's get back to the notebook editor. So we have already imported numpy with an alias np. So now we are gonna create our first nd array. So I'll name it as a equals to np. I want to use array range method, and then how many elements I want 20 elements. So 20 elements. And then what shape I want, I'm go with the shape of sorry, I have to go with the reshape. I will go with the reshape of 4 comma 5. Yep. And similarly I'll create one more nd array. So but this time I'm gonna go with a range of 20 with the reshape of 5 by 4, 5 by 4. And then I'll create one more array. So np, it's arrange, arrange, array range, and I'll go with the 16, and I'll give the reshape of 4 by 4. Yep. So it's all set. Our arrays are ready. So if you want to see all the arrays one by one, you can just let me go up and click on B and enter and A, execute it, and here is the array A. This is how it looks. And B, enter, B, enter. This is what the 5 by 4 array. You can see the shape. The shape of 4 by 4, 4 by 5 is different than compared to the shape of 5 by 4. Okay, one seems longer, others one seems wider, the A seems wider, and B seems longer. That's where we'll have different types of dimensional, n-dimensional array, longer n-dimensional array, and wide n-dimensional array. And similarly, let me check C also. Yeah, this is what these are, the n-dimensional arrays for us. Okay, so now what we are going to do is we'll start utilizing our attributes. I'll begin with the shape first. So I'll take a dot shape as it is an attribute. You don't need to use a parenthesis. So it's 4 by 5. It's 4 by 5. So immediately what I will do is I will use a dim. I use n dimension. Ndim. I'll use ndim attribute because ndim attribute is to measure the, is to give the how many number of axes that this array consists of, whereas the shape will give you how many total dimensions of the array it consists of. Okay, so total, let me give a dot ndim. Everybody knows it would be, answer would be 2, and here is that it's 2 because it consists of 2 axes. You see that it consists of 2 axes. One axis consists of 4 elements and another axis consists of 5 elements. So that's the reason it's a 4 by 5. It's m 4 rows, it's n 4 rows, m 5 columns. It's n by m and 4 by 5. So, and similarly we can check for the B shape and then B and dim. Same C shape, it's 4 by 4 and C and dim. Okay, and now let's look into the one more attribute, and after that what we have here is we've seen ndim shape, and I'll check for size. So a dot size, what is size? It will give you the total number of elements of that array. So I'll go with the size, and here is that a consists of 20 and B should also consist of 20 as absolutely, and C how many it will consist of. Let's check. Here it is 16. Fantastic, no issue at all. So that's what a size attribute will do. So now I'm gonna check with D type. What's the type of that element? So for that, what I'm gonna do is I'll say n dot D type. Sorry, a dot D type, and it's int 32. It's int 32. So 32 divided by 8, it would be 4. The byte size of each element would be 4 bytes, but that we are gonna get from using item size attribute. So then let me do for the B and C. So all are of int 32 types. Then what we have here is item size. So what is item size attribute will do? The item size attribute will give you the size in bytes of each element of the array. So what I'm gonna do is I'll say a item size, and it's 4 bytes. I told you it's 4 byte because it's 32 divided by 8, it's 4 bytes. So item size will also be 4 bytes, and C, item size will also be 4 bytes. Okay, fantastic. So now the last one, but not the least one, it was just a minute, data. It's a data. So this will give the buffer containing the actual elements of the array. So normally we won't need to use this attribute because we will access the elements in an array using indexing facility. Let me do that. A dot data and execute it, and here is the memory location exactly in hexadecimal. If you want to convert it into the decimals, you can convert it, it's not a big deal. Then let me go for the B, and this is a different location. You see that 96F8, and after that this 4 digits has changed. And similarly, let me check where the C array has been stored. It's been stored in a different location. It's a 79F0, 5CB0, and 6A80. So these are all the fundamental and very important attributes of ndarray.